Welcome back everybody, my name is Dustin. In the last video, we finished up working on the sound system and adding in sound effects. There's still plenty of polish that could be done with sounds, however, it is good for now, and we'll revisit that later on. If you've been following along with the community at all, I recently asked you guys to do a fun little challenge. The challenge was to download the tiled map editor, create a map with different layers and tile sets, export the map as a new Lua file, and try to load the map in our engine. If you were able to get it done, or at least tried to get it to work, post that in the comments below. I'm really interested to see what you guys came up with. If not, that's okay. We're going to go over how I did it now. First thing we need to do is download the tiled map editor. So just type in tiled download, and then you'll get there. Get the latest release, and then go to download. The software is free to download and use. However, if you can afford it, please donate to this developer because this is an amazing software that is constantly improved upon. Now, I've already downloaded this myself, but you just go to download and you pick the installer for the correct OS that you're using. I was using Windows 10 64-bit. I've already downloaded it, installed it myself, so I recommend you do that as well. Okay, so now that we have that downloaded and installed, let's go and create a simple map that we can use in our game engine. So just open up tiled and we'll get here. All right, so now that we've opened up tiled, let's create a new project. So new project. I created inside of our editor, inside of the assets, I created a new folder for tiled maps. And we're going to create a new one and we're just going to call it test map. Okay, so now that we're in test map here, I want to add in a new map. Everything is going to be correct here, orthogonal, CSV, write down, and the current window that we're working on is 640 by 480. That will be pretty small for tiles, that's because our tiles, so we need to change this to 16 by 16. 16 by 16. I want to scale it in the engine by 2. So we need 20 tiles, so 320. 320 times 2 is 640 by 15. That will give us 240. 20 by 15 tiles, that's what I want. Go OK. And then we created our little map here with a tile width of 16 by 16. And we need to add in a new tile set. So that's the first thing we'll do. And I'm going to want to embed it in the map and go browse. I also added in 4 tile sets that we're going to be using for this test. A simple collider, which is just a 16 by 16 square. I created an A-sprite, which is red, and the alpha channel has been lowered, so it's semi-transparent. So we're going to load that in. Okay, and it's 16 by 16. We don't want to change anything else, and we're going to call it collider. Perfect. Okay, that's all it is here, is this tile. And we're going to add in a new tile set as well. So here, new tile set, we're going to add in all 4 because we want to be able to have multiple tile sets on different layers so we can load those in. We need to be able to parse different tile sets. So same thing, browse, forest, we'll leave it as forest, 16 by 16, perfect. And we'll do 2 more. Tile set, browse, ground tiles. I'm going to change this just to ground. Okay, and 1 more. File, new, tile set, browse, village. Cool. And okay, cool. So our first layer, we'll change this and we'll just call layer 0. We'll start at 0. And we'll say ground. Cool. And we'll go to ground. And we click on this. So each tile, you see each tile has a unique ID. So anywhere you click, each tile has an ID. So we need to remember that for later. But let's quickly make this map for us. So add in, let's get our 4 corners. All right, and then let's add our top and bottom. Or our sides, sorry. All 4 sides. Now, if you've used tiled before, it has lots of features. We're not going to go into all the features of tiled. We're just going to make a quick map. Then here, the shape tool, select the center, and just open this up. Cool. So we have that. Let's do a quick save. And we want this to save in our tiled maps, and we'll call this test. Let's go test map. Cool. Okay, so let's add another layer, new tile layer, and we'll call it 1. And we'll just call this one objects. Cool. And for that, let's start with the forest and let's add in some bushes here. And we'll just go add in a few bushes, some here as well. Add different colors. Cool. And some flowers here and there. Okay. Now let's actually go to, you see how this has a fence and the village also has a fence, but I want to use multiple tile sets on the same layer. So let's try to add that in now. So we'll go to village and let's just create a quick little fence here. Go back to our stamp. Let's go back to our forest real fast and let's just add a few more things in here. Let's get some flowers. Add the flowers in. A couple mushrooms. Cool. And save that. And now let's just add in our colliders. Collider, and let's create another layer, new layer, and we'll call the layer 2. And we'll just say collider. Cool. And we'll just add our colliders in. So that's something that we can add a box collider to. Cool, and save. Now that we have a simple map created, let's export it as a Lua file and then interpret and parse the data. So you go to File, and we want to go to Export As. And we're going to change where we're putting it. We're going to go to Assets, Scripts, and let's add in a new folder here. And we'll just call this Test Project. Test Project. Cool. And we're going to want to change this to a Lua file. And we'll say testmap.lua. Cool. Save. All right. So let's go into our engine and take a look at that. So if we go here in our assets, scripts, we're going to have to refresh. Refresh. There it is. Cool. And open this up. And let's open up our testmap.lua file and take a look at the data. Looking at this data, there's a lot of stuff that we can ignore, but we really do care about the tile sets because that's what we put in there. And we care about the layers. Okay, so let's first take a look at the tile sets. The tile sets is just a table of all the different tile sets and their data. So if you see it has collider here, that's the name of our collider, and then it's the first GID is 1. Okay, and it's just telling you, and then it has an image width, tile height. Okay. So, and then this one, you see how it has a first GID 2, and then if we go down here, this one has a first GID of 1282. These are basically offsets, because if we go back into tiled, each tile has its own ID, and we're talking about that before. So this one was put in first, second, third, fourth, right? So it's going to look at it like that and give it an offset based on the tiles. So this one only has 1, and its ID is 1. We go into this one, so the first ID is actually 2. But then if you go down over here, it's 1279 for the last tile. So 1280 is the tile count plus where it's starting for the 2, which means our first GID is going to be 1282. Okay, so that's perfect for us. That's what we need to know. Okay, so what's the easiest thing that we can do? First thing we want to do now actually is, remember that utilities file that we created before for the asteroids game? Well, let's recreate it. Okay, so here, new, and we'll put it in scripts. And we'll say utilities.lua. Now we don't actually want to recreate it. We want to open up the old one and just grab the files from it. So here's our old utilities. There's some functions that are going to be specific to the asteroids game that we don't want. But we do want this load entity one because this one will be very helpful later on. So we might as well grab it and copy it and put it into our new utilities file. Now this utilities file, we'll just keep adding stuff. We won't add any game specific stuff to this file. This will just be a bunch of helper functions that we can keep adding new functions to help us later on, so we don't have to rewrite them. Let's see if there's any more that we can use. Load background, we'll leave that one. Check pause, we don't really need. Get the random positions, we can keep that. Let's put that in here. Cool. Then we don't need anything asteroid related, don't need any of this, don't need anything projectile related, but get digit, it's good. We'll take that one as well. We're not going to need this one right now, but we're just throwing it into our utilities file. So let's put that in there. All right. Okay, so if we go back to our test map, the tile sets, we only care about a few things. We want the name, first grid, tile width, tile height, and the image width, image height. Everything else I don't really care about. Okay, so we can just get rid of that. You can probably do other stuff with it, but I don't really worry about it. I guess we could use the tile count. We only need a few things from the tile set, so it would be a good idea to create a Lua class for tile sets. So if you remember how to make a class, we'll just go tile set is equal to table, tile set dot index is equal to tile set. And we're going to want a function to create a tile set create, and that'll take in a table of the parameters, okay? And then we'll say local this is equal to a table, set meta table, this, self, return this. Cool. So what are we going to need? We're going to need the name. That's the name of the texture or the sprite sheet. Params.name. Then we need the columns. That's equal to params.columns. Width, params.width. Height, params.height. Tile width, tile height. And then first grid, params dot first grid, and that's good. And one thing it doesn't give us is the rows. So if we go into this file again, it doesn't give us the rows, so we're just going to need to calculate that really fast. So let's go here, and we'll say this dot rows is equal to params dot height divided by the tile height, params dot tile height. Okay. Then we're also going to want the last ID. So last grid or grid ID is equal to math.floor. This dot rows times this dot columns plus this dot first grid minus 1. That should be good to get us started. So now we want to create a function for loading the tile map. So we'll just say function load map. That'll take in a map definition or a table. And that's all this really is. So see here where it's return and it's this here and it's got our table. So we're just returning a table here. So what we want to do is go through this table and deal with those values. And the map def is the table that is being returned. Okay, so let's assert map def and say local tile sets. Because what we're going to want to do is loop through this and grab each of the tile sets. So we're going to have a table of tile sets because we're not always going to have 4. Sometimes it'll be 1. Sometimes it could be 10. We don't know. So we want to be able to go through and get all those tile sets and create a new tile set. So we'll go for kv in pairs mapdef dot tile sets do, and we'll just put an end there. And now we just want to create a new tile set for each pair. So new tile set is equal to tile set create. Now we're creating it with a table. So name is equal to v.name. Columns is equal to v.columns. Width v.width, v.image width, sorry, height is equal to v.image height. Tile width is equal to v.tile width, and then tile height. And then we want to get the first GID. First GID is equal to v.first GID. Cool. I think that should be good. And then we want to insert the new tile set into our tile sets table. So we go table dot insert tile sets new tile set. Cool. All right, so now that we have all the tile sets into our little tile sets table, it's time to go through all the layers. So here, if we go to tile sets and we get to layers, layers is what has our data and stuff that we need. So we can get the rows and the columns for the map from the height and the width given by our layer. And we can also determine the layer based on where it is in our layers table. So which element. So if this has a layer has a table of layers, so which one is it? So that's what we can do. We can get the layer from that. Okay, so the first thing we want to do is loop through the layers and create the tiles. So we go loop through the layers and create the tiles. Cool. Tiles. For AV in pairs, and that's map def dot layers do okay. So let's get the rows. So local rows is equal to v dot height minus 1. Then because the rows are actually starting at 0, then local calls or columns is actually equal to v dot width. Local layer is equal to k minus 1. All right. So now we want to loop through our rows and columns. So we go for row is equal to 0 and rows do. And then this is going to be a nested for column is equal to 1 in calls or column do end. Okay. So now that we got our rows, our columns, and our layer, we need to go and look at the data. So let's take a look at this data here. Okay. Looking at the data, it does look like just a bunch of numbers. However, each number corresponds to a specific tile ID from the tile set in tiled. We need to have a way to determine what tile set this ID belongs to. But first we need to grab the ID from the data. So we need to get this ID out of here. Okay, I know this looks like a 2D array or a two-dimensional array, but it's actually not, because you can see there's only has these two, so it's just one big table. If it was 2D, it would have brackets around each one of these. It would have your squiggly brackets. Okay, so this is actually just a 1D or single dimension array spaced for readability. So in order to treat this 1D array like a 2D, we need to grab the data based on the current row multiplied by the number of columns and then add the current column that we are in. That will give us the correct data to use based on the row and the column. Okay, so let's do that now. So we want to get the ID, so we'll go local ID is equal to v.data at the current row times the number of columns plus the current column. Okay. All right, so now let's do a quick check as well to see if the ID returned is 0. If the ID is 0, that means there's no tile there at that location. So tile just gave it an ID of 0, saying that it's an empty space. So we're just going to want to skip that particular ID. And if you remember from our asteroids game, Lua unfortunately does not have the continue keyword. So we're going to have to use a goto. Now you can use there's probably a different way to do it as well, but the goto works for me. So if I go ID, if ID is equal to 0, then go to continue and let's just put continue right here. Continue. Cool. All right. All right, so now that we have the current ID, we need to determine what tile set this came from. Each layer could be using multiple tile sets. So we're gonna need to create a function that goes and checks to see if that ID exists within this tile set. All right, first we'll go local tile set is equal to get tile set. That'll be the name of our function. And that'll take in our tile sets table that has our tile sets and the ID. So let's take this and create that now. And we'll just go up here and we'll create that right here, right below tile sets. And we'll go function, create tile set, or get tile set, sorry. And in get tile set, all we're gonna do is loop through all of our tile sets and check to see if that tile ID exists for that particular tile set. So we'll go for k v in pairs tile sets do if v. Now we're gonna need to create a new function for the tile sets, and we'll just say tile ID exists, and that'll take the ID. Then we're gonna want to return v, and v is the tile set itself that we'd be returning. And if not, we're gonna return nil. Okay, so now we need to make this function. If you see right here, this is actually a member function for our tilesets class. So let's take this here, take the whole thing, and we'll just put this right here, and we'll go function, tileset ID exists, okay? And all that is we're returning to see if the ID is greater or equal to the first GID and ID is less than equal to the last GID. That means this particular tile exists in this particular tile set. So return ID is greater than equal to self.first GID and ID is less than or equal to self.last GID or last grid ID. Cool. All right, let's go back down here. All right, so now that we have that function, let's add in a small assert to assert that the tile set exists. So let's go tile set, and then we'll just say tile set does not exist with ID. Cool. Now that'll show up in our console if the assert fails. All right, so now that we have the tile set, we need to determine what our start X and start Y positions are, because if you remember from before, our sprite needs those values to determine where in the tile sheet or sprite sheet to parse. So now we need another little function to get those positions, okay? So we'll also add this function as a member function for our tile set, and we'll call it get tile start XY. So we'll say function tile set get tile start X and Y ID. And that takes in the ID and N. Okay. So if we open up tile again and take a look and we click anywhere, so each one has an ID. ID is great and it works, but we need the X and the Y position so we know when we do our UVs where in this map, this tile map it is, okay? So that's what we're gonna do. All right, so I'm gonna put a little assert here as well to ensure that this tile exists. Even though we already called this previously, I want to ensure that it does exist for the one that we're trying to get. So we'll say tile ID does not exist in tile set self.name cool, and then say local actual tile ID is equal to ID minus self.first GID. Okay, so because the first GID or first grid ID is actually an offset. So if we go back again into tiled and take a look here in the collider, you see if we got this clicked, its ID is 0. So if we go back into our map and take a look at the collider, right? Wherever that is, in the collider right here. See, it says first GID is 1. Well, we don't want 1 because we know it's not 1, but that's the first grid ID. It's given that 1. Okay, so if we go back in here, we want to subtract our first GID. Cool. So that gives us our actual tile ID. And then now we want to get the start Y. In order to get the start Y, we want to go local start Y is equal to math.floor. And we want to take the actual tile ID and divide that by the number of columns. All right, then we want to say local start X is equal to math.floor of the actual tile ID. This time we want to modules the columns. And that'll give us the actual ID. Or that'll give us our start X. So start X, which column are we in? This one will give us the row. This one will give us our column. Okay? And then we want to return start X and start Y. Awesome. So if we scroll back down here, and now we want to go local start X start Y is equal to tileset get tile start XY and send in the ID. Now that we have the start X and start Y, we need to determine the transform position of each tile. Now, I want to scale the tiles by 2 for this because we don't actually have the camera zoom and stuff like that functionality. We'll eventually be able to control that and more later on. But for now, let's just add the scale in. And we also created the map as 320 by 240. So that's 640 by 480 if scaled by 2. So let's create that scale. Local scale is equal to 2. And let's get the position. So local position is equal to vec2, because I want to create a vector here. And let's do this. And do this. And go column minus 1 times the tile set dot tile width times the scale. And we want to do the same thing for the Y, but this one is row. So the row times tile set dot tile height times the scale. Awesome. Now we have the position, we have the scale that we're using, we have the start X, start Y. So now we can actually create our entity. So let's create our new tile entity. So local, and we'll just say tile is equal to entity, and we'll just give it, we can say tiles per group, and then we will entity, or not entity, sorry, tile dot add component, and we're going to add the transform component. And that it take in the position. And the position is a vec2, and we already created that vec2 right here. All right, and it's going to need the scale. And we can go vec2, scale, and rotation, but it's going to have 0 for rotation. Okay. So now we have the transform component. What else does our tile need? It needs the sprite component. And we're going to want to use the sprite that is returned when we add the components. So go local sprite is equal to entity dot add component sprite. I want to say the name of it. So tileset dot name. Then we need the width. Tileset dot tile width. Then we're going to need the height. Tileset dot tile height. Then we need to start X, start Y. And the layer. And we determined the layer up here. Cool. Now that we have our sprite component added, we're going to want to generate the UVs. So we don't need a comment for that. It's going to be self-explanatory. Sprite, generate UVs. Okay. Inside of the tiled map editor software, there's probably a way to add the colliders in correctly instead of the way that we did it. However, I don't really know how to do that yet, but we can use our collider layer. So we can just check to see if the tileset name is equal to collider, because that's what we gave it. So if you come here and you see we gave it the name collider, we can check to see if the tileset name is equal to collider. And then if it does have that, we can just add a box collider component. Okay, so let's do that right now. So here, and we can say if tileset.name is equal to collider, then entity.add component. Then we can go box collider. I believe we made a box collider, so we'll add that in. That'll be tileset dot tile width, tileset dot tile height, and then the offset we're just going to have it at 0, 0. Cool. And we can either hide the sprite here if we want to, so we can go sprite dot be hidden is equal to true, but we'll hold off on that for now. Okay, and I think that's it. That's all we need to load our map. All right, but there is another thing that we're going to need. So if we go back into our old asteroids files, we had that asset defs file right here, and we need to have this function. So let's take this function here, the load assets, and create our own little assets def. Let's move this and go back into our utilities here and put that function in there as well. Here, okay? And we'll change this to take in a new table because it might not always be named asset def. So we'll just take that there and make the assets. Cool. All right. And we're going to have to create a new asset defs for this game here. So here inside a test project, create a new item. Asset defs.lua. Is that how I want to do it? Actually, let's just do it all. Asset defs.lua. Cool. So let's just copy all of this from our asset defs, our old one, paste it into here, and get rid of all of these except for, let's just get rid of all of them except for one. We don't need any music right now. We don't need to worry about sound effects right now. We just care about having this here. And we're going to want to name our textures the same name that we name them in the test map. So we're going to want collider, we're going to want forest, ground, and village. So here we'll just do collider, and where did we put that? The path. It's in assets, textures. So let's get rid of all of this. Go assets, textures, collider. So we got collider, forest, ground tiles, and village. And this is, we named that ground. Ground, tiles, forest, and village. All right. Okay, so let's open up our main, and we have to make some changes in here. So we no longer want this. We don't want any of this. We can add that back in later if we need to run the asteroid game. Okay. And we're going to have to load in some stuff. So we're going to want to go run script. And what do I need? I need the asset defs.lua. So that's in assets, scripts, test project, asset defs. So assets, scripts, test project, asset defs.lua. We need that one, and we can copy this line because everything's in a similar spot. In test project, what do we have else in test project? We need testmap.lua. Testmap.lua. Now it's returning a table, but let's create this as a function that is called. So we'll say function create test map. And then right at the bottom, so hit just control end, we'll just say end. Because it's right now it's just returning a table, but returning it to what? You know what I mean? So we want to return it in this function, okay? So it won't just return it right away as an anonymous table. And then we need to have our utilities, and that's in scripts utilities, okay? So we can just copy this, get rid of this, scripts utilities.lua. Now, before we do anything, let's just run it and see if it runs. Just because we probably made some mistakes, and we'll see. Yeah, so we got a mistake here. That's fine. And that's at utilities 190, expected a bracket. So let's go see. So utilities, and we can go G, control G, 190. Okay. Expected a bracket for close because there's 1, 2, 1, 2. Where to expect that bracket? Probably here 1, 2, 3, 1, 2. 3. Cool. Run it again. Awesome. So it didn't load the map because we didn't call that. All right. So let's go back to main and see if this works for us. So we'll go local tileset or tilemap is equal to create test map. I believe that's what we called it. Let's go check really quick. And we'll just copy that and bring it over. Create test map is correct. And we can just go assert tile map and then just say load map. And that will take in our tile map. Tile map. And let's run it and see what happens. Okay, so we got some errors here. That's all right. 190, attempt to index the nil value entity. That was my fault. Probably you guys probably already caught that. I probably, yeah, right here should be tile. I'm so used to putting entity everywhere. Did I do it again? Yeah, right here. Okay, try it again. Lots of errors. Right here, texture collider was not created correctly. Okay, so we probably didn't put it in the correct spot. And our assets, textures, collider. Oh, silly me. Yeah, I forgot that we need to load the assets, and that's going to take in this table. So right here, before we load map, we actually want to load our assets. So go load assets and go assets defs and run it again. Bang, look at that. See, we got our map created for us. Perfect. And we can make it full screen. Look at that. So we loaded this map in, it loaded in the colliders. Now let's see if we can actually hide those for us. Because if we did it correctly, these should actually be box colliders. So we go in here and go to our utilities. And right here, hide our sprite. So if it actually is a box collider, this will be hidden. Okay, run it. Awesome, look at that. So we loaded a map. This is directly from Tiled. So our engine can actually create maps. It has box colliders. We can hide it. So there's another little challenge for you guys. Create a player and have him or her walking around in the map. See if you can do that. All right. That's it for this video. If there's any questions, comments, or you have a better way to do it that you did yourself, leave it in the comments below and I'll take a look at it. I'm interested to see what you guys came up with. All right. Take it easy.